Hello, everyone. Welcome today to the pgEdge AI DBA Workbench Postgres Live. Um, I'm Antony Pegg, the Director of Product Management here at pgEdge, and I've got with me Paul Rothrock, our Solutions Engineer, who's going to be running the demo for us. And we also have the estimable Dave Page, who is not only the founder of pgAdmin, but also our CTO and creator of the AI DBA Workbench. So, without too much ado, I'm going to run you through quickly what we're going to cover today and a few details before Paul does the demo. So, as we're going to cover what the AI DBA Workbench does. We're going to walk you through how it manages your estate and your entire fleet at a single glance. We'll walk through the monitoring, how you can monitor your cluster, the server, and all the different database metrics. We'll cover off our AI capabilities with Ellie, who is our built-in AI assistant. The how you can configure the AI DBA Workbench to work for your system, including how you get alerts, how you can do blackout windows, how you can control access to it, and then how you can get started with it yourself. And then we'll wrap up with some questions and answers, for which we have Dave here for the highly technical deep dive questions. So about the AI DBA Workbench itself, like everything we do here at pgEdge, it is 100% open source under the PostgreSQL license. And this tool, the Workbench, it works with any PostgreSQL instance that's any PostgreSQL database that's 14 and above. Doesn't matter where it is or who it's from. It itself has a ton of built-in probes and there's nothing that you install, no agents that you install on your servers itself for these probes to run. It's a remote collection. I will say that there are a couple of extensions that if you add, we're able to gather even more statistics, things you'll see like CPU and memory usage and so forth. But then under the hood, it's running a three-tier anomaly detection, starting with the normal statistical baselines that you get that are procedural, and then leveraging which I will say, leveraging the optional AI layers. So you don't have to enable the AI layers, but if you do, then you get the amazing benefits of being able to detect similarity of patterns, and then you have the ability for the LLM to classify the errors and to analyze them at a deeper level for you and to help guide and walk you through how to fix whatever it is you may be seeing. And that's what we have Ellie for, our AI assistant that will help walk you through, give you guidance on what the issues may be and how you can fix them and help you run them. Now, the AI Workbench itself, it's also self-hosted and air-gap ready. You can run it anywhere, and you bring your own AI. So you can use Claude, OpenAI, Gemini, or even local models. You can go do that through Olama or any OpenAI API compatible system, such as LM Studio, for example. And then, as always, our stuff this is available on GitHub in the pgEdge organizations. There's a repo out there for it, so you can get it directly. So that's our brief overview. With that, I'm going to hand it over to Paul to walk us through it in detail. Over
Great.
to
Thanks, Ant. Could you be sharing? Can you share now? Yeah. Okay. Let me go ahead and share my screen. Okay. So this is what you see when you first log into the AI DBA Workbench. It gives you an overview of your entire Postgres estate. It gives you current warnings and any alerts, and then there were, and any restarts. So the first thing you see when you log in is the top things that you need to take care of. So on the left side here, you can see all of the clusters that I'm working with. So it works from Postgres 14 to 15 with different kinds of replication. So the Postgres 15 and 16 clusters are using, traditional primary replica replication. The Postgres 17 cluster is using Spock, and the Postgres 18 cluster is using a mixture of the two. So it's really very flexible in terms of adding clusters and can really fit with your architecture. So let's drill down into one of the clusters. So let's go to the Postgres 16 cluster. You can see the number of, at the top here, you have the AI overview. So it gives you sort of the same overview that you got when you logged in but for each individual cluster. You can see the number of servers that are in their current state. And then below that, you have the event timeline. So you can see, all of the events that have happened, the cleared alerts. You can see when the alert's fired. Um, yeah. And then if you click on them, you drill down into, you can see which alert was fired, which one, when they were cleared, and all that great stuff. And so this kind of looks like a normal alerting system that's sort of tuned for Postgres. You've got the top metrics that you need to see as a Postgres DBA. That you don't want a transaction ID rollover. You want a good cache hit ratio, and you get the number of transactions and checkpoints. So this is sort of above the fold. You get all of the activity that's happening, all the most important metrics. Below that, you have the current active alerts, and there's really two kinds of alerts, and Ant touched on this in his presentation. So there's your normal threshold alerts, which are this value is above or below a value that you set. And there's also alerts that are called anomalies. And this is when the statistical analysis or the LLM has detected when something is wrong. So it's not like you have to set up all of the alerts. You don't need to know what you're alerting for. It will learn your patterns and it will alert you on its behalf. And it's also tunable. So if it has an alert, you can flag it as a false positive, and that allows you to sort of train it like you would train a junior DBA about, no, that spike at connections at 3 o'clock in the afternoon, that's just the accounting department running a report. So it not only will alert you of things that you don't notice, you can actually tell it that's fine. But if there's a spike in connections at 3 a.m., it'll still fire an alert. Below that, you've got the topology and then replication information. And so if we drill down even further into a server, you get the same sort of metrics that you got before, but you get it just for that specific server. And then you also get things like system resources. So this requires the system stats extension to be installed. But it is just querying the database. Like Ant said, there's no agent to install, which is actually it really simplifies the rollout because you can just add a Postgres server to this and it will start connecting and doing loading information. Um, but you'll notice on all of these, there's this little icon here that says AI analysis. So let's go ahead and do an AI analysis of the cache hit ratio. And so these cells you see at the top, these are tools that are built into the MCP that's inside the AI DBA Workbench that allow the LLM to have really deep knowledge and context and get really useful information out of your metric system so that it can do an analysis. So it's collected all that and it's sent it off to the LLM. And after a minute or so, depending on how productive Claude decides to feel today, we'll get a really great analysis full of useful information. Here we go. So you get a summary at the top. It notices the trends and patterns in your data. So it gets all of the metrics data and the LLM is able to interpret that. So you can get a very good rundown of when things happened and what happened. You can see it also has recommendations for configuration analysis or for configuration. Um, but the really great thing is that you can do things like run diagnostic queries directly from inside of your metric system. And this sort of fixes so back when I was a system administrator, when something would happen, I would have three windows open. I'd have Grafana, I'd have a Google search, and I'd have a terminal window. And this sort of brings them all into one spot. So they're not doing switching between different things, and it gives you access to a lot of really great knowledge because this includes a RAG server that is trained on Postgres and pgEdge documentation. So it's already got all of that context that it's providing to the LLM as well. And you can see that icon is, on pretty much every metric and alert in the system. So if we go to the alert here, you can see, the memory usage size, you can get an AI analysis on that specific alert. So this really gives you, again, the ability to have a lot of relevant information on alerts, really at your fingertips. And then another feature I'd like to show you on the server page is the query summaries. And so this is something that I really recommended to DBAs is go into your database, see which queries are using the total time and optimize them down because they're your low-hanging fruit. But if you click on one, it'll give you a visual diagram of how the query is working. and then it'll also give you a text one, and then it'll also give you an AI overview of that specific query. So if you want to tune specific queries, this will help you to find those ones that are really going to make the biggest impact. Let's see what else. So the other thing that this has is Ellie. So this is a chatbot that uses the MCP and the RAG server and really gives you a natural language interface to your metrics. So you can ask things like, what configuration changes should I make to the Postgres 17 cluster to optimize performance? And so again, you see these tools being fired off, and these are all things that are giving the LLM a lot more power and actually saving tokens by giving it a better way to talk to the database. And after a few minutes, and this is actually kind of a big question too, so I can understand why it's going to take a little while to think about it. Any minute now, we'll have a really great answer. Here we go. So yeah, you get, let me expand this a little bigger and make it easier to see. So it gathers a complete picture of your entire cluster, and it gives you, critical recommendations. So these are the things that you should change first, and then, going down in order. So and it even gives you the commands to do this, which is really great. And again, that's completely built in, and it provides you with an interface where you can ask questions about anything about your cluster. When was the last blackout? When was the last time a certain server was rebooted? And it will know about that. And this also operates over an HTTP API. So if you wanted to do it in another interface, that's totally possible as well. So in terms of sort of other features that we have the ability to set blackouts. So we can add a new one-time blackout. So if you're going to be doing maintenance, you don't want it to be firing off alerts because you know the server's down because you took it down. So this you can do at really any level, and I think that's, one of the great things about this is at any level you have a lot of control and a lot of information. So I can say on this server, I'm gonna for the next hour I'm gonna be fiddling with it. So I'll create a blackout, and that will pause all of the alerts for an hour. You can also do scheduled blackouts as well. So if you have maintenance windows, you can schedule that on an estate, group, cluster, or even server basis. So let's get into the configuration. So in here, you have full role-based access control. I don't have another user, but in terms of, so you have the ability to set permissions on, let's go ahead and create a group here, show you how it's done. So let's create a group called new guys. And you don't want to give the new guy too much power. So we'll go in here, we'll pick his group, and then we'll grant him just read access on all the connections, and then no admin permissions, and then you can even grant MCP privileges. So you can give it, here are all the tools that you can do, and you can limit them to specific ones. So let's say we only want them to see the system information. And so now we've created a group with limited access that we can add to, so the entire team can log in without it being giving them, root access to the entire metric system. We also have here are the 34 probes. So these are the defaults. So when you add a server or a cluster, these are the ones that are going to get set. These can be set again on a per cluster or per server basis. And you can configure the retention. You can configure. So if you know that you don't have system stats installed, you could say, disable system stats in here. So we disable pgstat.io so that when you don't have it, so you don't have it. Then there's also alert defaults. And again, these are the defaults for the entire system or any new ones that you add, but it will, you can customize them on a per cluster or per server basis. So there's a bunch of different alerts that are available. You can even change the priority. So if you want this one to be a warning instead, there you go. So again, really highly flexible. We're not here, we're just to give you suggestions on what you should do, but it's highly customizable depending on what you want to do. And then in terms of notifications, so when an alert fires, there are four channels. So there's email, which is email. You give it an SMTP server and it'll send an email. We also have Slack channels that you can configure as well. So if you're using Slack for alerts, that's in there. Mattermost, who is one of our partners. So this is really important for air-gapped environments where they can't be going out to Slack, but they still need alerts. And so they can host Mattermost on pgEdge and then send alerts from the monitor to Mattermost. And then we've got webhook channels. So these channels are really flexible. You can define, you got the HTTP method. You can specify, headers that you want. You can do different kinds of authentication. And then we even have templates, which are written in the Go template syntax that you allow you to specify what information is in that webhook. And so this is, if you got something like PagerDuty, this is great for that. And then finally, we've got memories. So I don't have any memories in here, but you can actually tell Ellie, remember that I don't know, we run Postgres on port 5000. And it will remember that. So when it gives you commands, they will have the correct port number on there. And finally, let's take a look inside each individual cluster configuration. So we go in here, we can see the topology of it. And then you can, again, do alert overrides, probe overrides, and then even specify, notification channels. And then to organize them, you can create cluster groups. So let's call this one normal replication. And let's put, let's see, Postgres 15 in there, and then Postgres 16. So you could see this being used for different regions or different tasks, but it gives you the ability to organize your Postgres estate that way. So yeah, I think that's the end of my demo. Do we have any questions?
We do. So first question we've got come in is, do you have to have your client running to get any of these alerts, or are these alerts running in the background?
So these alerts are running in the background. The architecture of the AI DBA Workbench consists of four parts. So you've got the server, which has the RAG and the MCP in it and serves the HTTP API. You've got the client, the web client, which is just a Node.js application that runs in the browser and uses the HTTP API. But then the other two are the collector, which does what it says on the tin. It collects the information from the systems and puts it into a Postgres database. And then you have the alerter, which is running as a separate process. These could, as long as they have connections to the Postgres database, they could be on separate machines if you wanted to for durability. So no, you don't need to have the server running for the alerting to work.
Okay. Uh, Another one is, how does the collector handle connection pooling? If I'm already maxing out connections on a busy server, does it add pressure?
I think that's a great question for Dave.
Thanks, Paul. So you can limit the number of connections to different database servers in the configuration to avoid that problem. And internally, the collector will use its own connection pools to make sure that it's using connections as efficiently as possible. One of the things that we try and avoid, for example, is running lots of probes in sequence and opening and closing a connection very rapidly to run each of those probes. So we'll hold them open for a period of time and then close them when they sit idle for a while to minimize the load on the monitored servers as much as possible.
All right, thank you. If you are using a third-party AI like Gemini or Claude, can you limit the usage to control AI costs?
Not within the workbench itself. We would, at the moment, advise limiting that within your own Claude account, where you can set budgets and limits for overspend and so on.
Can you access the MCP directly without needing to use the UI?
Yeah, so the server process that sits behind the web interface is actually a combination of an MCP server and a REST API server. So what it's doing is exposing the normal JSON RPC MCP interface, which provides MCP tools, all the tools that you mentioned, I think 20 or however many of them there are. It provides those to Ellie when you're using our interface, or you can collect Claude code or cursor directly to it over HTTPS. And then those tools are available to Claude. It have exactly the same access to your infrastructure that Ellie does. So if you prefer to use Claude code, maybe you're monitoring a server that you're using in development, for example, such as when I've been working on this, I've had Claude code connected to my entire test cluster. So you can do that, and Claude has the same information available to it that Ellie would. Even the knowledge base that gives the very specific additional information to complement the pre-existing training of the model that you're using. So I mentioned also there are REST APIs available in the server. So things that are not managed through the LLM. So for example, adding a server or reconfiguring alerts. One example, Paul mentioned that you can customize the alert settings on a per cluster or per server basis. None of that is done through the LLM because there's no need. It's much more traditional REST API type interface from the web application to the backend server. So you also have access to that if you want to integrate with other systems that you've already got. It's a fully open API compatible interface, fully documented and included in the docs. You may have noticed when Paul was flicking through the settings, there was one tab he didn't visit, which had tokens on it. So your users can create API tokens that give them access to that REST API, which are scoped to a maximum of the permissions that their owner user has. So nobody can use an API token to gain more privileges than they're intended to have. But they can downscope them as well. So if you know that you're building an application, it's only going to use a couple of APIs, it's good practice to scope the token you use to that so that it just has access to those two particular APIs. So there's really lots of ways you can integrate with this and connect up your own applications far beyond just the alert channels and such as the hooks that Paul showed us.
Oh. Do you have a question of what does the storage footprint look like at scale? If I'm monitoring 50 servers with 34 probes each, how fast does that data store grow?
So my test infrastructure, I don't know the exact numbers off the top of my head now, but it was sitting at one point around the 20 gig mark, having been running for, I think it was about 4 months, monitoring 17 servers with a sort of mix of workloads. One of our projects on GitHub is a workload generator. So it's sort of like a benchmark tool, but it's designed to mimic an application in real world use. So there are pauses. It's not hammering the system constantly. It's just running through the typical queries an application would do, but trying to mimic, if you selected a workload profile for a local office, you've got peaks of activity, 10, 11 in the morning. It all slows down at 1 o'clock and so on when people go for lunch. So my cluster was running lots of different workloads with lots of different profiles constantly. And I think it was about 20 gigs for those 17 servers over 3 to 4 months. Now, the way we store data within the system is that we are using partition tables, partition by date. And basically what we do is we just drop partitions when all of the data in them ages out. So when it gets everything in a single partition passes the retention time set for the probe that's putting data in it, then we just drop that partition. So you will typically get to a steady state once you've collected enough data to meet the retention time of all of your probes. The usage should level off.
Are those retention times configurable?
Yeah, so Paul showed us the configuration page for the probes, and one of the options on there was the retention time. So for each probe, you can specify, for tracking PG stat activity, for example, because that can be quite a noisy system view. You might configure that to only keep data for 30 days, whilst tracking some other stats that we know don't change very often. You might keep those for much longer length of time. So what Paul showed us was the system-wide defaults, which you can override in that UI. But if you hit the settings options for a cluster or a individual server, you can override the settings for the probes and the alerts. In fact, the threshold-based alerts, you can override those settings for that object. So if you do an override at a cluster level, it will override it for all servers that are members of the cluster. And if you override it at the server level, it's just for that particular server. And no matter what you customize, it's always the lowest level customization that takes effect.
If I remember correctly, you can also customize how often it actually samples and collects data, correct?
Yeah, that's just another one of the settings on those probe configurations, the frequency with which that probe is executed. And as Paul noted, even whether it's executed at all.
Cool.
In the case of some of the probes, I mean, Paul showed us things like CPU usage on the chart there and mentioned that that requires the system stats extension. The queries that we saw at the bottom, where he clicked and could see the query plan and get the analysis of that query plan, that requires pgstat statements, for example. If you have those probes enabled, but the extensions are not installed, then what you'll find happens is that we'll still run the probe periodically, but it will fail cleanly. So it will check, it will find that the right extension is not installed, and then just carry on about its business without bugging you. And the UI will hide away those panels, so it will collapse them, so you don't see a whole great big page of blank CPU usage, memory usage, disk usage graphs, and so on. It will just collapse up those accordions and put a hint in the collapsed accordion just saying install the system stats extension to see the data within this section. So it's designed to be as clean as possible to allow you the flexibility to have or to not have system stats or pgstat statements and to deal with that cleanly, even if you leave those probes enabled.
Cool. So I might take this one out of order because I think it related a little bit. What's the failure mode if the collection goes down? Do we lose metrics for that window or does it backfill when it recovers?
If the collector goes down, it has no way of backfilling because it obviously can't go back in time and look at Postgres and say, hey, what were these stats at this point in time? Because Postgres doesn't keep that info. So what we would typically recommend is some sort of watchdog or just a monitor just to alert you should the collector go down. When it comes back, it will just carry on collecting metrics as it was before, so you might see a small gap. In future releases, we're going to be looking at how we can offer high availability for processes like the alerter and the collector, so you can actually run them on multiple machines at once for both load balancing and HA purposes.
Cool. And I think this is the last question as far as I know. How do you handle secrets management for the database connection strings? We have compliance requirements around credential rotation.
Yeah, so the database connection strings for the various components that make up the workbench are basically stored however you would typically want to store them for any service that needs to connect to Postgres, so a pgpass file or a secured configuration file or certificate-based auth or whatever makes sense for your environment. The credentials for actually connecting to the monitored databases are stored AS AES encrypted within the Postgres data store. So if you need to rotate those passwords, you will need to go and reset them periodically through the UI or the API. So that can be automated, but we do need to store connection credentials somehow.
Obviously. Yep.
Yeah.
Cool. Oh, we had another question come in. Is replication monitoring also included where installed? And if so, what sort of information is displayed here? Can you alert on replica-related metrics such as lag?
Yeah, absolutely. So we support Postgres' built-in binary and logical replication, as well as Spock multi-master replication. And as Paul showed us at the beginning, you can have clusters that are combinations. So it's quite common, for example, to have a Spock cluster where each node in the cluster is geographically distributed, and you have hot standby nodes. So you might actually have three Spock nodes, each with two hot standby nodes that are using Postgres binary replication. Um, the workbench is fully aware of topologies like that and will, unless you're doing odd tricks with IP addresses, will try and infer that automatically from what it can see in the way of replication connections, replication slots, and so on. And if it fails because you're using some method of IP addressing where the IP address on each host is not the same as what is actually seen, you're going through a NAT gateway, for example, then you can manually define those relationships between the cluster nodes. What the workbench will then do is monitor various metrics related to the replication and absolutely query lag, replication lag is one of those things. So it will be tracking those metrics, storing them just like any other metrics automatically because it can see that you have replication connections. And then there are also sets of alerts that will warn you, for example, when replication lag goes over a predefined threshold or if an anomaly is detected.
Cool. All right. That was our last question, but I got a little one of my own for Dave just to finish us off, which is out of all the stuff that's in the workbench when you were building it that we may or may not have shown today, what was the coolest thing for you that when you did it, you were like, yeah, this is a cool feature?
Um, oh, that's a really good question. Oh, dear. Um, so I used to work for another Postgres company and spent a lot of time building monitoring tools for them. And honestly, the what's really cool for me is not any one feature, although I do really like Ellie. Um, it's the fact that I was able to take everything I'd learned from 10 plus years of building that other system and take all the technical debt, the bad decisions, the things that couldn't be changed because they were built before Postgres had various features and that sort of thing, and were just going to be really hard to change, and basically do it all again from scratch. So I would kind of say the whole system. Um, I know that's kind of a cop out, but for me as a software engineer, being able to go back and like start from scratch and do everything with the latest technology, the latest good technology, um, and fix all the things that have been bugging me for over a decade about what I previously used to work on, and know that the result is far superior to the previous work. That's the coolest thing to me. Um, but yeah, I do really like Ellie as well. Um,
Brilliant.
well, it might be worth noting that Ellie is also, although she can't access your databases from there, Ellie is also on our website and our docs website, and has much of the same knowledge base behind her, as well as the same system prompts and personality and so on as she does in the workbench. Um, so it's that technology is something we've taken and put in multiple places because it seems to work so well.
Brilliant. Thank you, Dave. Thank you, Paul. All right. And thank you, everyone, for attending. I hope we answered all your questions. Well, I think we did. Please do try the beta today. It'll be coming to GA very, very soon. There is a QR code on the screen that you can scan. Otherwise, you can go straight to the link at our GitHub or pgEdge for the AI DBA Workbench. Thank you all very much for your time.
Yeah,
Thank you.
thanks.